Okay, so just going to run through this assignment then. We have to write this as an expression where all terms are in the form ax to the b. So I'm going to do for that first one 8/3 x, and the square root of x is x to the power of a half, plus, so that's a half, and it's x to the power of minus a half. It's on the bottom of the fraction this time, and it's a square root, and then minus 8 x to the minus 2, and then minus 5/2 x to the minus 5 again. Okay, because it's on the bottom of the fraction. So that was number one. Number two, so we've got, again, to start off with, minus 9/4, and that's x to the power of minus 3/2. And then we've got minus 5/8 x to the minus 1, minus 6/5 x to the minus 3, and then plus 5/7 x to the minus 5. Okay, question 3 then. So if we take the square root of that first of all, actually maybe it's easier to write that 7p to the 7 q to the 6 over 8 p to the 4, and we're going to write this all to the power of a half. Okay, so we've got, if we're taking we apply this power to each of the terms, so 16 to the power of a half is the same as the square root of 16, so that's just 4. And then we've got a power to a power, so p to the 7 to the power of a half is p to the power of 7 times a half, so 3.5. I'm going to write as a fraction, so 7/2. And then we've got q to the power of 6 times a half is 3, all over 8p to the 4. 4/8 is just 1/2, and then we're going to do 7/2, and we're dividing, so we're going to subtract the powers, so 7/2 take away 4. Now if I think about that 4 as 8/2, I've got 7/2 take away 8/2, and 7/2 take away 8/2 is minus 1/2, or minus a half, and then we've still got our q cubed. Okay, I'll just check my answer quickly. Yep, a half p to the minus a half p to the minus a half q cubed. Okay. Right. So moving on. Question 4. Same sort of idea. So if we do the top first of all, 4 times 8 is 32, and then p to the 4/3 times p to the minus a third. We're adding the powers. So 4/3 add minus a third is taking away a third, so that's just p to the 3/3, which is just 1. So I could write p to the 1, I'll do that just for emphasis really. I could just write 32p. And then on the bottom we've got 7p squared, so 32/7, and then 1 take away 2, because we're dividing, is p to the minus 1. Okay, let's just double check that. 32p to the minus 1, great. Question 5. So solving this equation. Now the trick here is we've got a power, z to the 6, and then another power here, z cubed, and you'll notice that this power is twice this power, and then we've also got a constant term. So hopefully this kind of pattern suggests to you this is a disguised quadratic. So if we write that as 2z to the 6 minus 5z cubed, and then plus 2 equals 0. So because it's quadratic, we're going to get it equal to 0. Now, at this point, I guess you might say, I'm going to do a substitution. I think this might be helpful to think about it this way. So we can say that is, if we make the substitution, z cubed equals y, I can write this as 2y squared, because z cubed squared is equal to z to the 6. Okay, minus 5y plus 2 equals 0. And then I can factorise this. So if we do 2 times 2, is 4. Remember this method, I'm looking for factors of 4 that add up to -5. So -1 and -4 should do the trick. So 2y squared minus, I'll write what, -1y minus 4y just for emphasis really, and then plus 2 is equal to 0. And then we can factorise in halves, so we can take a y out there, so 2y minus 1. And then if I've done this right, that'll be 2y minus 1 there, and sure enough I can put a minus 2 in front to make it equal that thing there. So then y minus 2 is times by 2y minus 1 equals 0. And then we've got two lots of solutions, so either y is equal to 2 or 2y minus 1 equals 0, in which case y is equal to, add 1 to both sides, divide by 2, y is a half. So either y is 2 or y is a half. Now we're not quite done yet, because we need to work out what z is. So we said z cubed is equal to y, so, and y is 2, so we could say z cubed is equal to 2, which means that the z must be the cube root of 2, or 2 to the power of a third if you like. And then similarly, using the other solution, if z cubed is equal to a half, then z is equal to the cube root of a half, which I guess I could write as, if I wanted to, 2 to the minus 1/3. Okay, it's minus, so it's perhaps I should show a bit of simplification there actually. So that I could write as the cube root of 1 over the cube root of 2. That's just 1 over the cube root of 2, and hopefully you can see then why it's the same as that. Okay, let's just see how they've given the answers on this document. Okay, yeah, so they've given it in that kind of format there. Right, okay, so our final, yeah, just to make it clear, our final answers are this one and yeah, any of these, I guess. That was the way they showed it there. So z equals that. But any of these formats are fine. Okay, moving on. Question 6. So again, this guy's quadratic. You've got a 4 as a power and a 2 as a power. 4 is double 2, and you've got a constant term. So I can write that as x4 minus 2x squared plus 3. I collected everything, sorry, whoops, minus 3. I collected everything this side because it gave me a positive. Well, for a quadratic, it's like the squared term really, because we're going to make a substitution in a minute to make that squared. I want that positive because it's much easier to factorise then. So if I write here x squared equals y, then this becomes y squared minus 2y minus 3 equals 0. Hopefully you can see how to approach this. So factors of minus 3 that add up to minus 2. We've got minus 3 and plus 1. So y must be equal to 3 or y must be equal to minus 1. Now remember, x squared is equal to y, so we can say x squared is equal to 3, in which case x is equal to plus or minus root 3. And then if we say x squared equals minus 1, well, there's no real solutions to that because we can't take the square root of a negative number. So there's kind of no real solutions coming from that. So our only solutions are these ones, x is plus or minus root 3. Let's just check. Yeah, plus or minus root 3. Okay, question 7. So simultaneous equation, and not a particularly tricky one. You can substitute this easily into here because they're both of the form y equals. So if y equals x plus 4, then we can say, putting that in the top one, x plus 4 is equal to x squared plus 11x plus 25. So then if we take away x from both sides, we've got x squared plus 10x. And then we take away 4 from both sides, plus 21 equals 0. So get it equal to 0. We're looking for factors of 0 that add up, sorry, factors of 21 add up to 10, so x plus 3 and x plus 7. So therefore x is equal to minus 3 or minus 7. Now if x is equal to minus 3, using this thing here, minus 3 plus 4, x is 1. Using this again, minus 7 plus 4 is minus 3. And just notice those come in pairs. So those two go together and these two go together. So for instance, minus x is minus 7 and y equals 1 isn't a solution together because, I mean, for instance, minus 7, 1 does not equal minus 7 plus 4. So you can see that if you substitute it in. So the solutions come in pairs. Okay, let's just again check we've got that right. Yep, all good. Okay, so then solving this one. Now this one's a little bit trickier. So to substitute in, we've got to do some rearranging. Now the smart thing to do is to rearrange that for x. So if we say x is equal to 3 minus 3y. Now the reason that's smart is because you don't end up with loads and loads of fractions. So substituting that in, that's going to become, so if x is equal to that, substitute that into our, well, this is an equation for a circle, you might recognise that, I hope you recognise that. So 3 minus 3y all squared plus y squared equals 1. So expanding that out, we've got 9y squared minus 18y, so 3 times 3 minus 3y in the other bracket, and we do that twice, and then plus 9 plus y squared equals 1. Okay, if we move, we group those together, so we've got 10y squared minus 18y. If we take away 1 from there, we've got plus 8 equals 0. We can divide by 2 just to make that a little bit easier to work with. 5y squared minus 9y plus 4. So we're looking for factors of 20 that add up, so 5 times 4 that add up to minus 9. Factors of 20 that add up to minus 9, minus 4 and minus 5 should do the trick. So you can write 5y squared minus 4y minus 5y plus 4. Okay, factorising out, we can only factorise a y out of here. So 5y minus 4, and then here, let's just write that again, 5y minus 4. In order for that to work, we need it to put a minus in front there, and it's really kind of like minus 1, lots of that. Okay, then we can combine these two, so y minus 1 times by 5y minus 4 equals 0, and then we can say, finally, y equals 1, or y equals, so from this one, or let's do the working. So if that bracket equals 0, let's just come up here for a second, then 5y minus 4 equals 0, 5y is equal to 4, and y is equal to 4/5. Okay, so y is 4/5, and then just find the corresponding x values that go with them. So we could use our formula here. So if y is 1, then x that goes with it is 3 minus 3 times 1, 3 minus 3 is nothing, and then if it's 4/5, we've got x is equal to 3 minus 3 times 4/5. So x is equal to 3 minus 12/5, so that's 15/5 minus 12/5, which is 3/5. So 0, 1, and then 3/5, 4/5. Let's just see if we've got that right. 0, 1, and 3/5, 4/5. It's a relief. Okay, so that was that one. Question 9. Find the equation that passes through these points. Whoops, sorry, we've got question 10 there as well. Just move that down. Okay, question 9. So if it passes through these 2 points, let's find a gradient first of all. So gradient 25 y minus y over x minus x. So that's 6 over 4, 1.5. So our gradient's 1.5. So we know the equation equals y equals mx plus c. Let's write that first of all. So that's y equals 1.5x plus c. Now we also know that it goes through this point 219. So if we substitute in, we can find our value of c. So 19 for y, there we go, is equal to 1.5 times by x, which is 2, plus c. So 19 equals 3 plus c. C must be 16. So our equation is y equals 1.5x plus 16. Now the other way of doing that is, having worked out the gradients 1.5, you could use that other formula, just down here. So you could say y minus 19 equals 1.5 times by x minus 2. And if you expand that all out, you'll end up with exactly the same thing. Okay, or you could write our 1.5 as 3 over 2 as well. Okay. Let's just check. That's what we've got. Yeah, okay, they've given it just in that format. Okay, last question then. Question 10. So perpendicular to this line and passes through the point 10 minus 4. So let's find out the gradient first of all of the line given. So y, so we want to rearrange this thing for y. So if we add 2y to both sides, we've got 2y is equal to 3x minus 15. Okay, so I've just added 2y really to this side, and then I've changed the sides around. Then divide by 2, y is equal to 3 over 2x minus 15 over 2. So our gradient of this line is 3 over 2, so the negative reciprocal for a perpendicular gradient. So it's going to be y equals negative 2/3 x plus c, and if it's going through this point, let's substitute in. So we've got minus 14 equals minus 2/3 times 10 plus c. So minus 14 equals minus 20 over 3 plus c. Okay, if I write that as a fraction of 3, so minus 42 over 3 equals minus 20 over 3 plus c. And then hopefully you can see that c must be 22 over, minus 22 over 3. So the equation y equals minus 2/3 x minus 22 over 3. Or alternatively, you could say it's y equals, y minus 14. So that's plus 14 is equal, using the other formula, equals the gradient, which we said is minus 2/3 x minus 10. Okay, and if we expand that out, I think we'll get the same thing. So that'll be 20 over 3, and then 20 over 3, take away 14, which is 42 over 3. Yeah, you'll end up with exactly the same thing. Okay. Let's just check our answer. Yep. Okay, we're all good. Great. Okay, so I think that's all the questions.